This video, we're going to solve percent problems by translating words and phrases into symbols in an equation. I'm going to prefer the direct translation approach as opposed to using the proportion method, but you can use either method that you use in class that you understand. And I'll show you both methods with the first example. So the question is, what is 15% of $80,000? So I'm looking for my question word will be my variable. This is my X. My verb here is my equal sign. My of is multiplication. I'm going to use a star for multiplication so it doesn't get mixed up with the X that's there. And this percentage, I'm going to change it to a decimal. So remember, that's like 15 over 100, or this is going to be 15% as a decimal, like that. And there's my 80,000. So my equation turns into X equals 0.15 times $80,000. And that is $12,000. Go ahead and use your calculator to verify that. I'll also show you that I can take the A is the amount, B is the base, and P is the percent number here. So I have A over B equals P over 100. So I don't know the amount. I do know the base is 80,000. My percent is 15%, so that's 15 out of 100. And then I can solve it as a proportion where I cross multiply and solve for A, or I can see that I just need to multiply both sides by 80,000 to clear this denominator. Then 80,000 divided by 100 is 800, and then 800 times 15 is going to be 12,000. So A is 12,000. This was dollars. It's the same thing. It just gives, instead of calling everything X, it gives more meaning to call them A, B, and P. Remember, if you solve for P in your problem, you're going to need to change it to a percent by dividing by 100. So determine the answer to this next question here, 36 is 60% of what number? So let's set that up here. 36 is 60% of, means to multiply. Question word is my variable. So I'm going to multiply by 100. Then divide by 60. 6 goes into 360 60 times, and 60 is my answer. Okay, like that. Let's go ahead and do one more. This kind of crosses over into our next topic. So I'll do this one at the end of this video, and I'll also do it at the beginning of the next video. And that's number 53. So it's going to cross over into the idea of percent change, but it's not written as a percent change problem. So it says a person earns $2,500 or $25,900. in 1 year as their salary, and they get person earning an annual salary of $25,900 a year gets a 5% pay raise. What is the person's new salary? Salary means their income, and you're looking at annual salary because that's what was given to you up here. So don't worry about the per year part. Worry about that they're making 25,900 and you need to add 5% to that. So there's a couple different ways that you can do this. But I'm going to ask the question this way. What number is 105% of 25,900, or what amount, let's say, is 105%, because I need to keep all my old salary and add an extra 5% to it. So X is 1.05 times 25,900. I'm going to open up my calculator here. 1.05 times 25,900 gives me 27,195. Okay, another way that you could have done that is you could have just found what 5% was. That 5% of 25,900 is 1,295. And I could have added that 1,295 to my original. And this is more what we do with percent change. And so 0 plus 5 is 5. 0 plus 9 is 9. 9 plus 2 is 11. 1 plus 5 is 6. Plus 1 is 7. And then bring down that 2. And I get the same answer. Look at that. So a couple different ways. So I can find the amount of change and add it to the original here as a percent change problem, or I can say that it's 105% of my original if I am using this is of technique, which is the way that the problem was written. I guess that's good. I don't think I need to come back to that next time, but we're going to talk about percent change next time, where we do things that are like markups and markdowns, where things go on sale, for instance, or we add sales tax to something and so on. So, all right, I will see you for the next video where we talk about percent change, percent increase, percent decrease, which we also call markups and markdowns. So see you for the next video.